Okay, so a quick note before we do this identity on the polar form of a coordinate. So for example, if I have a coordinate here, normally we give our coordinate as x, y, but when we're doing polar coordinates, we use an angle. So I have an angle theta here. So my x coordinate would normally be how far out this is, and my y coordinate is normally how far up this is. So in this case, we're dealing with a unit circle, so the radius of this circle is 1. Okay, 1, minus 1, 1, and minus 1. So the radius of this circle is 1, which means the hypotenuse of this little right angle triangle I just created is 1. So if I want to find my x coordinate here, well, I can only always use cos, because cos theta is equal to adjacent over hypotenuse. And this is adjacent, this is opposite, this is hypotenuse. So cos theta equals adjacent over hypotenuse, x over the hypotenuse, and in this case, in the unit circle, the hypotenuse is always 1. So cos theta is equal to x. Sine theta is opposite over hypotenuse. The opposite is y. The hypotenuse is 1. So sine theta is equal to y. So I've got x and I've got y. So my x and y coordinate is now cos theta, sine theta. Okay. So you're going to use that in the following proof. So prescribed identity 1. So sine squared a plus cos squared a equals 1. It's a nice short proof. First thing, you do have to draw a diagram. Okay. Into your diagram, you draw your circle, draw in theta, draw in your radius of 1 here, your theta, drop your right angle triangle just like I did above. Let's call the point P here, and we call it cos theta, sine theta. Okay, so remember cos theta refers to your x, so cos theta refers to the length of this line, and sine theta is your y, so sine theta refers to the length of this line. Okay, so we're going to prove this just using our distance formula. So our distance formula, our square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's the formula we're going to use here, okay? So what we're going to do is we're going to find the distance from the point O here, the origin, to the point P. That's what we're going to do. So for the proof here, we're going to use the square root of these 2 points. So my first point O is 0, 0, and P is cos theta, sine theta. Okay, we call them x1, y1, x2, y2. So now the distance from O to P we know is 1. Hence, because that's the length of the hypotenuse, 1. Hence, 1, let's say the square root, so x2 minus x1, so cos theta minus 0 to be squared, plus y2 minus y1, sine theta minus 0 to be squared. That length must be equal to 1. Okay, so that's the square root. Cos theta minus 0 is just cos theta. To be squared, that's just cos squared theta. And then plus sine squared theta equals to 1. So how do we get rid of a square root sign? We square both sides. So cos squared theta plus sine squared theta equals 1 to be squared. Therefore, cos squared theta plus sine squared theta equals 1.